Today I want to make the pulley for this servo to work with this direct drive hub interface. First I need to calculate the diameter, and for that I need to know what the rotation angle is for each of the two parts. It will be the hub shifter rotation, which I know is 130, and for the servo I've wired up this temporary circuit. Not recommended to connect directly to these lithium cells, but they are discharged. So if I put it back to 0, it's 180, and put this on here, we can then see where it ends up if I give it 180. And it's clearly not the 180 that I paid for, but that's okay, because as long as I know what it is, and it looks like about 170, I can compensate for that in the calculations. So let's go over the diameter calculations. The hub interface is restricted in rotation by the internal shift mechanism of the hub to 130 degrees, but it will actually do a total of 200 degrees of rotation. The servo, as we know, if we want to use its maximum potential, is 170. So therefore we calculate the cable pull that's required for this hub interface, and that will be this equation here, and we end up with 38 millimeters. We then want to calculate what this diameter needs to be, and that will be this equation here, and we come up with 25.6. Now that will be, because this is the diameter of this hub interface, which is 32 millimeters, just over, plus the cable thickness, which is 1.2. And so this, we then need to take off the cable thickness, so the diameter of the pulley would need to be 24.4 millimeters. Now that's becoming rather small diameter, so what I'm going to do is increase it, because it will reduce the risk of fatigue in the cable. It also means that I can adjust the under and overdrive in code instead of actually adjusting the cable itself, and it's also very easy to restrict the servo's rotation using code. It's just numbers. So what I've decided on is 29 millimeter diameter, and that will give a rotation of the servo of 144 degrees, which is around 85% of its rotation angle. I don't want to go much less than that, because you start to lose the accuracy. I'm going to make the pulley out of 5 layers of aluminium, 1.8 millimeter thick roughly, because I don't have a lathe to turn it. I need 2 of 29 millimeter diameter and 3 of 37 millimeters. I'm going to go through my scrap aluminium collection here and find some suitable pieces. I've found all these bits of aluminium, some of which are offcuts from the original larger diameter pulley that I made for the first automatic shifter. I'm going to choose the best ones and mark them out. I'm going to cut the 3 layers together because it was easier than marking out the ones that had holes already drilled in them. These coping saws work perfectly fine on aluminium as long as you're careful. I think I need a better line, I can hardly see that. That's a lot better. I'm not too bothered at the moment about getting a perfect circle. There's a lot that can be done with a file afterwards to tidy things up. Alright, I think that's all cut. Okay. That should be 37 millimeter diameter, huh? Just going to give them a quick clean up with the file whilst they're still together. That's them all cut out now. Next thing is I need to attach one of these. I'm going to use this one, and I think I'm going to cut a spline into the aluminium to mesh with this, because relying just on the rivets with such a small diameter and high torque is not really going to be a good idea, I don't think. So that's the spline now cut. It's just a long process with a file to get it to fit nicely. I'm not going to rivet the plastic to the metal, I'm going to sandwich the in between the layers. So the next step is to put all 5 layers together, and in these spots here drill the rivet holes. I'm just going to drill a couple to use as locators. I've drilled an 8.8mm hole in the bottom piece here. Fits nicely onto there. And then I'm going to put these other 2 layers on top, and then we're going to rivet the whole lot together. I've got this wire here, which is just a little bit too thick. It's 2.5mm, but it's all I've got in the way of aluminium wire for riveting. So I'm just going to use that. So I'm going to hand drill this because I want it nice and firmly clamped together whilst I do it. And that should fit the wire. Yeah, slightly oversized, but it'll all clamp together alright when it's riveted. I've gone and drilled another 2 holes because the first 2 I drilled were indeed oversized. Somehow a 17/64 drill bit ended up in my collection, and I thought it was a 2.5mm. I've spent a bit of time with a file and these vernier calipers, just making the discs a bit rounder, just to make it look a bit nice. It's not really necessary, but now I'm going to just sand them down, spin this up, sand them a bit, and round over the edge just to make the cable run a bit nicer on the surface here. Starting to look quite nice now. Just the centre one to clean up, and then we'll start working on the cable grip. I'm just experimenting to see if a single slot will be enough to grip the cable. And it clearly isn't enough to hold it, so 3 slots would be necessary. I think 3 slots is definitely the way to go. There's no chance that's going to pull out of there. So that's the slots now cut. Yeah. Now I need to cut out these sections here to allow the cable to drop right down into the slot. I've just test fitted a piece of cable into the grip, and that works nicely. As you can see, the cable is a bit below the pulley surface, so that if it wraps around, which could happen at the extreme ends the servos travel, it's not going to affect the diameter. Notice that there's quite a bit of a gap underneath the pulley when I put it onto the servo. So I've come up with a clever plan. I'm going to swap around some of these discs and lower it down by 1 layer. So if I swap these 2, it should allow this to move up by 1 layer, and so the pulley will be 1 layer lower. And that works perfectly. In case you're wondering, the cutout for the slots still line up. It just zigzags in a mirror image of itself. And just do the countersinks for the rivets. That should be right. Getting the length of the rivet correct takes a little bit of skill, but something like 1/2 to 3/4 of the rivet's diameter sticking out on each side. It does depend a bit on the depth of the countersinks as well, of course. I think that one's probably going to be about right. And I'm going to start at the bottom because it's the messiest one. Turn it over, and then you just flatten this out completely. Like that, it's just about perfect. It's now finally in one piece, and next I'm going to clean up the rivet heads with a bit of sandpaper, make it all look nice, and that will be it finished. And there we go, one custom made metal pulley. Sure, it's possible to buy an equivalent that would have done the job, but I actually quite enjoy the process of making it. And it's also such an important part of the whole project that it's worth getting it right. And this metal version should be nice and long lasting. So, thank you for watching.